Hello, my name is Jeff Bull, and I'm a systems engineer with Cisco in the San Francisco Bay Area. Now, we've been building networks for a long time, and as network admins and engineers, we're all comfortable with the idea of taking a standardized set of configurations for switches, routers, and other networking devices, and using them in multiple places to develop a network that is necessary to fit a business need. And that's worked as a really solid process for a long time. One of the big downsides to it, though, is us. We remember and we learn lessons over time, and that's fantastic. We earn certifications, and we learn how to develop networks better, how to troubleshoot them, and that's all really good stuff. One of the big downsides to that is, because we carry over our lessons and what we've picked up on over many years of doing these roles, these configurations for businesses typically follow that sort of path and don't always focus necessarily on what a business needs to be successful. Now, that could be good, that could be bad, but at the end of the day, it means that we end up having relatively non-standard network configurations and oftentimes more complicated than they probably need to be. Now, I worked for a company a number of years ago where I actually got my start as a network engineer, and a director that I worked for told me at the time that if we're developing and designing networks that require certification level experience, like a CCNA or higher, to be able to develop and manage, we're doing something wrong. And at the time, that put me a lot on the defensive because I was like, hey, I just got my certification. You're telling me that somehow my knowledge, my experience is worthless? It did take me a long time to realize what he really meant by that, which is if it takes us learning a certification and a deep dive into how a network functions in order to support a network or design a new network, we're taking the wrong approach to developing that for a business. These days, businesses and their applications are the primary focus. Applications are what allow businesses and companies to be profitable and successful in their company goals. And if what we're focusing on is developing networks and designing them to fit traditional networking methods and not what's best to support that application and its users, we're doing something wrong. Now, at Cisco, what we've kind of taken the approach of is rather than working through all these different tools that have sprung up in the last 20 years to help solve a lot of these problems that use traditional sorts of methods like creating templates or grouping those templates or just automating that process, those are all good ways of doing things, but they only get us so far. We realized that the only way to really move this ahead is to create a new way of developing networks, designing them, and deploying them, because they cannot just be static things anymore. And if we're too focused on the endpoint or the physical piece of hardware that we're configuring, we're going to get lost in the mire and we're never really going to be as successful as the business needs us to be. And these ideas like IT is a cost center or we don't add value, they're old mindsets, but they do still exist for a lot of people. And there's no reason that should be the case. Networking designs and networking systems are so much more advanced than they used to be that we can really add a lot of value. So what we have developed is a new way of approaching the network, specifically on the campus side. We do this by leveraging hardware and software. Now, I know that's not new to anybody, but in our minds, they are the core tenets of how you develop a network, and they are equal in this. So this can no longer be about we buy all the hardware we want and maybe we'll get some software, a management tool to help us. That's no longer the case, and it will not be the case ever again. What we have to focus on is having hardware that supports the physical functions we need a network to take care of for us in a business, and the software to tell it what to do, using our intent. And what I mean by our intent is, what is it that we intend that network to do to be successful for the business? And again, I don't mean which protocols we deploy, how we configure a physical port on a switch. I literally mean, how do we plug these things in and then take a step back and say, what is it I generally need this network to do? What that should be is, I need it to pass traffic from one place to another. I need it to allow a user to connect and gain access to those applications so that they can do their job. I need it to be running all the time, and I really need it to be secure. Those are the important things. What we have developed is a software-hardware combination, and in the middle sits a platform called a controller. Now, this controller acts as a central point to allow you visibility to what the physical network is doing on a daily basis, and then manage it using software. Now, I know what you're probably saying to yourself is, Jeff, that's not any different than what we've done in the past. And in the abstract, you're probably right. But in this new method, what the key difference happens to be is that controller is physically able to talk the disparate languages of all these different hardware. If you've been buying, let's say, Cisco switches and routers and wireless access points for the last 10 years, you'll know that operating systems and code versions and functionality change wildly over the period of time based on the hardware models and things like that. New functions and features and support comes out for those hardware platforms over time. And if you're always chasing chasing this task of keeping code updates in place and all that, you never get caught up with anything. So what we really need is something in the middle that can talk the various languages of all these older devices and new devices, so that as we need new hardware, we can bring it in, but we're not constantly worried about, are we in sync with everything all of the time? We don't necessarily need to be on the same exact code version all the time. We just need something that can talk to everybody at the same time and manage them as we need to. Then on the software side, we can't just look at this anymore from a traditional method where we have SNMP and SSH and those sorts of access controls to get into a device. We don't want to sit back and think about, all right, I'm going to log into this box and type these commands and something magical will happen. Yes, you can absolutely still do that, but it takes time. And every little bit of time is something where you're not spending your energy on more important things like solving a real business challenge for the organization. Our software, called Software-Defined Access, is more of a workflow that allows you to go in, design your network from a site perspective and from a holistic globalized perspective, where you're making decisions about what IP pools do I want to use generally? Where are my networks going to live? What buildings am I in? Where are they physically located? Let me upload some floor plans. You're then going to create policies by which all of this is managed. And by policy, I'm referring to not just security policy where I traditionally would use something like a NAC solution to say this port's on, this port's off, that sort of thing. I want to make much higher level decisions about this group of users from my directory services environment. That's where I've identified them. This group of users can talk to this group of servers or other resources in this way. Or these people can't go here. That's what I want to be able to say, because realistically, from a business perspective, all we need to do, and the business just cares about, can my users here do their job that lives over here? That's it. So spending all kinds of time in the middle thinking about what ports to open, all that, doesn't scale. We've been dealing with it for a long time, and it's a nightmare. Let's get away from that. So at Cisco, we developed two main platforms. DNA Center, which is our controller that talks to the physical network and allows you to manage that network without having to touch every individual box by creating a fabric. That fabric allows us to look at the network as a holistic entity and make decisions about how the network will act, regardless of what devices physically live in that network, so long as we have enough physical devices to allow users to access that network and to interconnect everything together, with great support for older systems as well. And on the software side, we've incorporated the software-defined access workflows, which allow us to easily develop and deploy our networks and secure them. We secure those using a policy engine. In our case, that happens to be ICE, or the Identity Services Engine. This is what becomes the policy engine for all things Cisco. Every bits of information comes in there, and we use those policies to manage what happens in our network holistically. And then finally, we have our assurance piece. Assurance is literally assuring that things are happening the way that they're supposed to in the network via machine learning and human readable information. Now, we also came out with a hardware platform, as you'd expect. We've been running many of our models for several years now, the 3850, the 4500E, etc. And they're all fantastic and all fully supported. But we also realized that we needed to have a hardware platform that could scale for us over the long term, because if we're focusing on rapid change and rapid deployment with software, we can iterate that fast. We need to have hardware that doesn't also require constant physical iteration to work. So we came out with the Catalyst 9000 series using our UADP ASIC, Unified Access Data Plane. And this ASIC is a fully programmable piece of hardware that allows you, through the controller or through direct programmability, make changes to those devices on the fly whenever you need to. That's critical to this, because now we don't have to focus on refreshing hardware constantly to keep up with the times. We can keep that hardware in place as it needs to be in place and refresh when it makes sense for us, while making sure that we have the software that effectively deploys everything. Hopefully this is helpful. Please let me know if you have any questions. Thanks.